Welcome, everyone. Today, we delve into a topic that not only impacts our present but shapes the very future of our planet. Is climate change a natural occurrence, or are we, as a species, responsible for the drastic changes Earth is undergoing? Let's uncover the truth. The science of climate change is more solid and widely agreed upon than you might think. But the scope of the topic, as well as rampant disinformation, can make it hard to separate fact from fiction. Here, we've done our best to present you with not only the most accurate scientific information, but also an explanation of how we know it. How do we know climate change is really happening? Climate change is often cast as a prediction made by complicated computer models. But the scientific basis for climate change is much broader, and models are actually only one part of it. And, for what it's worth, they're surprisingly accurate. For more than a century, scientists have understood the basic physics behind why greenhouse gases like carbon dioxide cause warming. These gases make up just a small fraction of the atmosphere, but exert outsized control on Earth's climate by trapping some of the planet's heat before it escapes into space. This greenhouse effect is important. It's why a planet so far from the sun has liquid water and life. However, during the Industrial Revolution, people started burning coal and other fossil fuels to power factories, smelters, and steam engines, which added more greenhouse gases to the atmosphere. Ever since, human activities have been heating the planet. We know this is true thanks to an overwhelming body of evidence that begins with temperature measurements taken at weather stations and on ships starting in the mid-1800s. Later, scientists began tracking surface temperatures with satellites and looking for clues about climate change in geologic records. Together, these data all tell the same story. Earth is getting hotter. How much agreement is there among scientists about climate change? There's no denying that scientists love a good old-fashioned argument. But when it comes to climate change, there is virtually no debate. Numerous studies have found that more than 90% of scientists who study Earth's climate agree that the planet is warming and that humans are the primary cause. Most major scientific bodies, from NASA to the World Meteorological Organization, endorse this view. That's an astounding level of consensus, given the contrarian, competitive nature of the scientific enterprise, where questions like what killed the dinosaurs remain bitterly contested. Scientific agreement about climate change started to emerge in the late 1980s, when the influence of human-caused warming began to rise above natural climate variability. By 1991, two-thirds of Earth and atmospheric scientists surveyed for an early consensus study said that they accepted the idea of anthropogenic global warming. And by 1995, the Intergovernmental Panel on Climate Change, a famously conservative body that periodically takes stock of the state of scientific knowledge. Currently, more than 97% of publishing climate scientists agree on the existence and cause of climate change, as does nearly 60% of the general population of the United States. How do we know climate change is caused by humans? Scientists have studied past climate changes to understand the factors that can cause the planet to warm or cool. The big ones are changes in solar energy, ocean circulation, volcanic activity, and the amount of greenhouse gases in the atmosphere. And they have each played a role at times. For example, 300 years ago, a combination of reduced solar output and increased volcanic activity cooled parts of the planet enough that Londoners regularly ice skated on the Thames. About 12,000 years ago, major changes in Atlantic circulation plunged the northern hemisphere into a frigid state. And 56 million years ago, a giant burst of greenhouse gases from volcanic activity or vast deposits of methane, or both, abruptly warmed the planet by at least 9 degrees Fahrenheit, scrambling the climate, choking the oceans and triggering mass extinctions. In trying to determine the cause of current climate changes, scientists have looked at all of these factors. The first three have varied a bit over the last few centuries, and they have quite likely had modest effects on climate, particularly before 1950. But they cannot account for the planet's rapidly rising temperature, especially in the second half of the 20th century, when solar output actually declined and volcanic eruptions exerted a cooling effect. Bubbles of ancient air trapped in ice show that, before about 1750, the concentration of carbon dioxide in the atmosphere was roughly 280 parts per million. It began to rise slowly and crossed the 300 ppm threshold around 1900. CO2 levels then accelerated as cars and electricity became big parts of modern life, recently topping 420 ppm. The concentration of methane, the second most important greenhouse gas, has more than doubled. We're now emitting carbon much faster than it was released 56 million years ago. How bad are the effects of climate change going to be? It depends on how aggressively we act to address climate change. If we continue with business as usual, by the end of the century, it will be too hot to go outside during heat waves in the Middle East and South Asia. Droughts will grip Central America, the Mediterranean and Southern Africa. And many island nations and low-lying areas, from Texas to Bangladesh, will be overtaken by rising seas. Conversely, climate change could bring welcome warming and extended growing seasons to the upper Midwest, Canada, the Nordic countries, and Russia. Farther north, however, the loss of snow, ice, and permafrost will upend the traditions of indigenous peoples and threaten infrastructure. It's complicated, but the underlying message is simple. Unchecked climate change will likely exacerbate existing inequalities. At a national level, poorer countries will be hit hardest, even though they have historically emitted only a fraction of the greenhouse gases that cause warming. That's because many less developed countries tend to be in tropical regions where additional warming will make the climate increasingly intolerable for humans and crops. These nations also often have greater vulnerabilities, like large coastal populations and people living in improvised housing that is easily damaged in storms. And they have fewer resources to adapt, which will require expensive measures like redesigning cities, engineering coastlines, and changing how people grow food. Already, between 1961 and 2000, climate change appears to have harmed the economies of the poorest countries while boosting the fortunes of the wealthiest nations that have done the most to cause the problem, making the global wealth gap 25% bigger than it would otherwise have been. Similarly, the Global Climate Risk Index found that lower-income countries like Myanmar, Haiti, and Nepal rank high on the list of nations most affected by extreme weather between 1999 and 2018. Climate change has also contributed to increased human migration, which is expected to increase significantly. On top of that, warmer weather is aiding the spread of infectious diseases and the vectors that transmit them, like ticks and mosquitoes. Research has also identified troubling correlations between rising temperatures and increased interpersonal violence, and climate change is widely recognized as a threat multiplier that increases the odds of larger conflicts within and between countries. In other words, climate change will bring many changes that no amount of money can stop. What could help is taking action to limit warming. What will it cost to do something about climate change versus doing nothing? One of the most common arguments against taking aggressive action to combat climate change is that doing so will kill jobs and cripple the economy. But this implies that there's an alternative in which we pay nothing for climate change, and unfortunately, there isn't. In reality, not tackling climate change will cost a lot and cause enormous human suffering and ecological damage, while transitioning to a greener economy would benefit many people and ecosystems around the world. Let's start with how much it will cost to address climate change. To keep warming well below 2 degrees Celsius, the goal of the Paris Climate Agreement, society will have to reach net zero greenhouse gas emissions by the middle of this century. That will require significant investments in things like renewable energy, electric cars, and charging infrastructure, not to mention efforts to adapt to hotter temperatures, rising sea levels, and other unavoidable effects of current climate changes, and we'll have to make changes fast. Given the steep price of inaction, many economists say that addressing climate change is a better deal. It's like that old saying, an ounce of prevention is worth a pound of cure. In this case, limiting warming will greatly reduce future damage and inequality caused by climate change. It will also produce so-called co-benefits, like saving 1 million lives every year by reducing air pollution and millions more from eating healthier, climate-friendly diets. The challenge is that we need to reduce emissions now to avoid damages later, which requires big investments over the next few decades. And the longer we delay, the more we will pay to meet the Paris goals. One recent analysis found that reaching net zero by 2050 would cost the U.S. almost twice as much if we waited until 2030 instead of acting now. But even if we miss the Paris target, the economics still make a strong case for climate action. because every additional degree of warming will cost us more in dollars and in lives.